So let's see an example of the Perceptron algorithm for binary classification in 2 dimensions. This will help us build intuition about what's happening when we move to more complicated structures. So let's say that we're doing 2D classification, so our weight vector only has 2 elements, and they both start at 0. So we first see an input vector of -2, 2, and we predict that it is 0 as a label. Our weight vector is 0, so we have no sign. The sign doesn't match, and so we make an error on this first example. So after seeing the first example, our weight vector becomes the first example. We add in -2, 2 to get the new weight vector -2, 2. Anything on that side of the hyperplane will be considered positive. And so remember, when you have a weight vector for a classifier, it points orthogonal to the hyperplane that will divide the classes. And so when you take the dot product with -2, 2, anything on this side will be positive, and anything on the opposite side will be negative. Okay, so now let's have a new example come in. This is our second example. And so this is at -2, -3. So we now compute the prediction. We multiply -2, 3 times -2, 2. We take the dot product of that, and we get -2. The sign of that is negative, so we don't make a mistake, and our weight vector remains the same. So a new observation comes in. It is at 2, -1, and our dot product is now going to be -6, so we make a mistake. So now we're going to take the sum of the vector -2, 2 and the vector 2, -1. We add those in together, and we now get the weight vector 0, 1. So now our hyperplane rotated from being a diagonal line to being a horizontal line. And so now anything that has a positive y dimension will be considered positive. So we get a new point that comes in, and it is at 1, -4. It's a negative label. We get that right, so our weight vector doesn't change. And so now we get a new observation at 0, 1, and the weight vector doesn't change.